In this video, I'm going to go over the project for 0605 Intro to Normal Probability Distribution. This is the project for Module 6, and just a reminder, when you are finished with this, please, you must download this document as a PDF and attach that to your submission. And the way that you do that is you just go to File, Download, download that as a PDF, and then attach that to your submission to get the points for this. So first I'm going to type in my name. I'm Mr. H. What period am I in? I'm in all of them. And the first question here, this is saying complete the table above, calculate the mean for all these players, and we'll fill in the table by calculating the deviation from the mean, the sum of the squares. We'll skip the variance, but we will do the standard deviation and the z-score for all of these players. So this is the team roster for the Lakers in 2021-22, and we're looking at the average points that they scored per game. And before I start doing this, I want to skip down and just show you, I gave you a formula sheet here at the end, and you can actually save this. You could use this on the test as well. But I want to start by looking at this bell curve. So this is a normal distribution. Whenever you see me talking about, or the text talking about a normal distribution, it has this bell shape. It's not skewed left, it's not skewed right. And you can see the mu, or the mean, is centered here at the center of the bell. And if I go out one standard deviation on either side, these little symbols are standard deviation. This contains most of the data, about 68% of the data. If I go out two standard deviations, this is 95% about of the data. And if I go out three standard deviations, that's almost all the data, about 99%. Going out further than that, more than three standard deviations would be an outlier. So that's why this is kind of important to see where the data lies when the mean is at the center. The other formula I'm going to use is this, the z-score formula. So here z equals x, the data point, minus mu, this is the mean or the average, divided by the standard deviation. This is a lowercase sigma for standard deviation. And the formula, the last one I'm going to use for standard deviation, today we're going to use this one for population. I gave you the one for sample also. This is a little different, but we're going to use the population formula for today. So let's get to it. Let's look at this chart. So up here, in real life, I would never do this by hand. What I would do is copy these, paste this into Google Sheets or into Desmos, and I would have that do most of the work for me. Today, I'm going to do this by hand just so you can see all the steps. It is kind of tedious, but I want to do it just so that you know kind of how it's done. But again, in real life, I would just copy this into Google Sheets or Desmos, or some of you have like a fancy calculator. I would do it that way. So I'm going to start by grabbing my calculator, and I want to put this into split view just because it's easier than flipping back and forth between two things. Here we go, and let me zoom in just a little bit. So my first step, this wants me to sum all the x's, all the data points, which just means add all of these up. So I'll do this by hand. 13.3 plus 6.4 plus 23.2 plus 7. Okay, and I got 172.2, so that's my sum of all these data points. So I'll write that in there. For this, we should all have the same numbers at the end. This also wants me to calculate the mu, or the average. So I'm just going to divide this number by the number of data points. Here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 players. So I am doing 172.2 divided by 15 data points. That means my average, or mu, is 11.5. 0.48. And for all of these numbers, I'm really just going to round to 2 decimal places. We're going to get some crazy long decimals here, and we don't need all those places. We'll just round to 2. Next is deviation from the mean. This is subtracting x minus mu. So I'm subtracting each data point minus the mean. My first one's going to be 13.3 minus 11.48. And that gives me 1.82. Next, I'm doing 6.4 minus 11.48. And here I get negative 5.08. I'll probably speed this up because it gets pretty tedious here. Next, I've got 23.2 minus 11.48. And that gives me 11.72. So these are all the deviations from the mean, all these numbers here. Again, you would never do this by hand in real life. You would put this into Google Sheets or in Excel or Desmos. Or here, it's fine if you just copy my numbers, that's fine. For the next one, we're going to do the square of the deviation. So I'm taking this number, 1.82, and I'm going to square it. And I get 3.31. Again, let's just round to 2 decimal places. Next, I've got negative 5.08. And I'm going to square that. I get 25.81. Negative times a negative is a positive. Next, I've got 11.72. And if I square that, I get 137.36. My next step is to sum all of these squares of deviations, so all of these numbers. I'm going to sum those, which just means add them all up on my calculator, or again, you could also just copy this into Google Sheets. Here I get 738.13. And my last column here is the z-score, which first I need the standard deviation. And we'll skip the variance because that's just the standard deviation squared. So we'll skip that one. To get the standard deviation, here is the formula that I'm using. I'm using the population because we didn't sample the Lakers. We're calculating the whole population of the Lakers. So here I sum all of this x minus mu squared, which we already did. We divide that by the number of observations, which I believe was 15, and then we square root that. Right, this was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, so I am going to take this number, 738.13. I'm going to divide that by 15, and then I square root that number. All right, so I'm getting 7.01. Now, this is a little bit off. I did this in Google Sheets already, so I'm going to put the actual number that I got here. So I'm actually not going to write this one. Those were the steps, but I want to use the exact number was 7.26. And my last step here to get the z-score, so I'm dividing the difference in the mean, the x minus mu, which was this. I'm dividing that divided by the standard deviation. All right, so the first one's going to be 1.82 divided by 7.26. And here, let's just say 0.25. We'll round to 2 decimal places. Next, I've got negative 5.08 divided by 7.26. And here I get negative, let's say negative 0.70 rounded 2 decimal places. Okay, so here is all of my data. Again, you could just copy these numbers into yours if you want. We should all have the same numbers. Or you could calculate these in Google Sheets. One thing that I want to show you before we move on, if I take all of these z-scores and I go over to my Google Sheets, and I paste these in, and notice what happens if I add all of these up. Yes, thanks for helping me. So if I add all these up, I get, it's a little bit off, but I'm getting 0. It's a little bit off because of the rounding. But when I add up all of the z-scores, they should always add up to 0 because these are all of the differences from the mean, from the center. All right, so that is all of part A. Again, we're going to skip the variance. If you want the variance, you just square this number. I'll show you how to do it. So 7.26 and square that. You get about 52.7, but we're not going to use that. You can skip that. For part B, remember you can copy all my numbers, that's fine, but for these should all be in your own words. Please don't just copy what I'm saying. So part B, what does the z-score determine? The z-score was this number here, or if I go down to my formula sheet, the z-score was this number here. It's kind of how far away you are from the mean, and anything bigger than 3 is an outlier. So what does the z-score determine? This is how many standard deviations a data point is from the mean. In your own words. Again, don't just copy what I'm writing, please. The next one, so analyze the player's average points per game that is the farthest from the mean. We'll evaluate the z-score and justify whether it's reasonable. So who was the farthest from the mean? Here I'm seeing it's LeBron James had the biggest number. He had a deviation from the mean 354, and his z-score was 2.59. So he is almost an outlier. If this number was greater than 3, that would be an outlier. So that's all that we have to say down here. So LeBron James is the correct answer. And tell me why. What is his z-score? So up here it was 2.59. Is this reasonable? How many points did he score per game? All right, and that was 30.3. That was his average points per game. All right, so I'm just writing it out like this because I do want you to write that in your own words. The next one, so analyze the player's average points per game that is closest to the mean. Evaluate the z-score and justify whether it's reasonable. So whoever is closest to the mean is going to have the lowest z-score. A z-score of 0 would be right here at the center, right at the mean. So here's 1, 2, 3 z-scores. Z-score of 0 would be right at the center. So I'm looking for who has the lowest z-score. And it looks like this one. I don't see any number that's closer to 0, and it could be positive or negative. It's really just which is closest to 0. This is a negative 0.2, so it looks like Talen Horton-Tucker. That's going to be our answer for this one. And then this is asking me evaluate the z-score. So tell me what is his z-score. And up here it was negative 0.2. And just tell me, what does that mean? It's very close to the center, right? So just tell me kind of something like that as you're writing your answer out here. Explain why negative z-scores are present. So negative z-scores mean that players scored below the mean, or they scored below average, right? So if the average, the closest to the mean, was about 10 points, and this guy only scored 6.7 points, he's going to have a negative z-score. Here's 6.4, that's below the average, so he's going to have a negative z-score. All right, so just tell me something like that. I said the negative z-scores, these are reflecting players that scored below the mean. Again, in your own words, please. What is the sum of the z-scores? So I did that for us here in Sheets. I added them all up. It was a little bit off. We got a small decimal here because of the rounding, but the answer should be 0. It should always be 0. If you add up all the z-scores, this should always be 0. The sum was equal to 0. Evaluate your calculation. Justify with statistic reasoning. So this is because we have an equal distribution of player points. Something like that. We have a lot below and above the mean. I think that should be good. Or you could talk about the positive, or the negative z-scores. Something like that. Again, I don't type out the answer for you. I wish I could, but please just make sure this is in your own words so that you're not getting scooped up by the Turnitin, like the cheating detection. It's fine that we're doing this together or that you're working together with your friends. That's all fine. Just make sure it is in your own words. Let's come down here to the last part. So this is part C. Compare the data above. Start by choosing 2 players from the table above. So I'm going to pick, I'm just going to pick these 2 because they're close together. And I can zoom in on this for us. But we should all have different players. So I'm going to pick Isaiah Thomas, and I'm also going to pick Russell Westbrook. But you should not pick these 2. You should pick 2 other players. All right. And that way we won't all have the same answer. So let's compare the data above for these 2 players. This is a table of their salary schedule. It looks like Isaiah Thomas, he's making 6 figures per game, $151,000. Russell Westbrook is making $44 million per game. Or is this per game? I think this is just their salary. And their z-score, they've already done the z-score for us. To compare average salary. So this will be different than the table above. But notice Russell Westbrook, he's got a z-score of 2.22. So that's almost 3, almost an outlier. Isaiah Thomas, he has a z-score of negative 0.62. So that's actually pretty close to the mean. It's very close to 0. And if we go back and look at our previous chart up here, this was looking at points per game. Russell Westbrook, he had a positive z-score that was almost 1, so he is scoring above average. The average was 11, almost 12 points per game. And Isaiah, he was negative 0.3, so he was below average points per game. So that will basically be our answer. As of course, there's other factors that come into it, with the NBA. There's marketing, advertising, You know, all these players, they have different jobs to do in the game. So we are just looking at this just purely based off of statistics, purely based off of Z-score. Even though in real life there's many more factors in this. So let me start by looking at Isaiah Thomas. So his average points per game, he was what? Let's see. He was 9.3. Which was a little below average. And let's look at his salary data. His salary data Z-score, it was also below 0. Right, he had a salary Z-score of negative 0.62. So this seems this seems fair, at least according to statistics. And our other player was Russell Westbrook. So let's look at his average points per game. He had 18.5. He had a Z-score of almost 1. He was at 0.97. Per game of, what was it? I think 18.5. This was above average. And let's look at his Z-score data. So for the points, he had a Z-score of 0.97. And his Z-score for salary was 2.22. So this, to me, at least statistically, I would say this is a difference here, right? I would expect the Z-scores to be the same. If this was 0.97, I would expect this to be also close to 0.97. Again, in real life, there's other things going on besides just points and salary. But for this, I'm going to say these numbers seem very different. All right, and I think I'll stop there. So you can add more to this again in your own words. So again, with this, you're just discussing their difference in Z-scores for their salary and for their average points per game, which was those two charts. That's pretty much it. Again, with this formula sheet, you can use this on the test, on the exams. This is a good reference, especially this for normal distribution for the bell curve. And that's pretty much it. Again, make sure this is all in your own words, except for this part. This should be the same as mine, all of these numbers. Your last step, remember you want to go to File, Download that as a PDF, and then attach that as your submission. All right. I hope that this video helped you out, and good luck with your assignment.